The mystery of the Triceratops' giant nose has finally been solved.
For a long time, scientists wondered why the Triceratops, one of the most famous dinosaurs with its impressive 3 horns, had such a large nasal cavity compared to most animals.
This part of the skull seemed disproportionately large, and no one quite understood the main function of such a spacious structure. Now, recent research from the University of Tokyo has provided clear answers. The scientists, led by researcher Seishiro Tada, used computed tomography scans, the famous 3D imaging exams, on fossilized Triceratops skulls. They reconstructed the internal anatomy, comparing it to that of modern reptiles and birds, and even assembled 3D printed pieces of the fossils like a puzzle to better understand how everything fit together. What they discovered is fascinating. The Triceratops' nose wasn't just for smelling, it was much more sophisticated than previously thought. Due to the shape of its skull, which blocked the normal pathways used by other reptiles, nerves and blood vessels needed to be routed differently, passing through the nasal region to reach the enormous snout. This demonstrates an evolutionary adaptation to support this exaggerated size. More importantly, within this giant nasal cavity were special structures called respiratory nasal conchae, thin, spiraled bony plates that considerably increased the contact area between inhaled air and blood. These structures, common in birds, are closest relatives to dinosaurs and mammals, help regulate body temperature and humidity. Inhaled air is heated or cooled, and humidity is conserved, preventing the animal from losing too much water or suffering extreme temperature variations.
In the case of Triceratops, with its massive head, which represented a large part of its body, this system functioned as a true integrated biological radiator. The nose helped dissipate excess heat generated by the size of the skull, protecting the brain and senses from overheating, especially during periods of physical exertion, such as fleeing from predators or fighting with other individuals. Although Triceratops was not a warm-blooded animal like us or modern birds, this advanced nose allowed for much better thermal control than that of common reptiles. The research filled an important gap in understanding the anatomy of horned dinosaurs, showing that the big nose was not just a decorative detail, but an intelligent evolutionary solution to cope with the demands of a giant body and a heavy head. This discovery, recently published, changes our view of how these incredible animals lived and adapted to the world millions of years ago. After all, Triceratops used its giant nose as a natural air conditioning system to keep its head cool and functional.